Okay, we're going to talk about high-level Chapter 8A, Measuring Angle Measurement. So first we're going to talk about what is a radian. A radian is an angle that's created when the length of the arc is the same as the length of the radius. So basically, if I was able to straighten out this line here, it would be the same length as the radius here. Now, regardless if that's 1 and that's 1, or this was 10 and that's 10, I'm still going to have the same angle because it would be the same proportion no matter how big or small if this is the same length as this. So that's what a radian is. Now, you've learned in the past, probably in geometry, that halfway around the circle is 180, all the way around the circle is 360. You might have also learned in geometry that all the way around the circle is 2 pi. So half of the way around the circle is pi radians. So the measurement of an angle that's half of a circle is pi radians, or you could say that it's 180 degrees. And we can use this ratio to help us convert between degrees and radian and measure of an angle. Now, the length of this would be pi if the radius is 1. I should write that down. The length of this is pi if the radius is 1. We'll talk about this formula in just a minute. Okay, so these formulas are in your formula packet. So the length of the part of the arc, which is the line at the edge of the circle, part of the circumference, is equal to the radius times the angle measurement in radians. So like I said, if the radius was 1 and this value here was pi, then I would have the length of pi. I'll say that again. If the radius is 1 and this is pi in radians, then the length would be pi. Now the area of a circle is 1/2 the radius squared times the angle in radians. Now in geometry you learned that pi r squared was the area of a circle. Well, let's think about this special situation. If I am using this formula 1/2 r squared, and let's say I go all the way around the circle, which is 2 pi, well, what is 1/2 times 2? That cancels out, doesn't it? And then I'm left with the area equals r squared times pi, which is the special case of a whole circle. Now this gives us the area of a part of a circle. A part of a circle is called a sector. Okay. Now we're going to do something that's going to help us with what we're going to be doing in the next lesson, H8B. So what we're going to talk about now is we're going to use the ratio that pi radians equals 180. Okay, and I'm going to draw a big circle. And in a traditional pre-calculus class, they would expect you to memorize this whole circle, and we're going to go over this in great detail right now. Okay, so starting here, we're at 0 degrees, or we could say it's at 360 degrees. Okay, you should know that if I go up here, that's 90 degrees, halfway around the circle is 180, and if I continue down here, we're at 270. I keep adding 90, and then add 90 to 270, we get 360. Okay, now we just said that this value right here, half of a circle is pi, and all the way around the circle is 2 pi, right? Okay, so if I'm only going up to 90, this is pi over 2, right? And if I add pi over 2 to this, I'm going to be 3 pi over 2 here. Okay, now we're going to be probably doing more things with other angles. So like halfway between these marks, halfway between 0 and 90 is 45 degrees. Halfway between 90 and 180 is 135. Halfway between 180 and 270 is 225. And halfway between 270 and 360 is 315. Okay. So let's figure out what the radians would be. So half of pi over 2 is pi over 4. If I add pi over 4 to pi over 2, I'm going to get 3 pi over 4. This is 4 pi over 4. Here we have 5 pi over 4. This is 6 pi over 4. This is 7 pi over 4. And 8 pi over 4 is 2 pi, right? Okay. Now, what if I was going in thirds? Then I would have 30 degrees, I would have 60 degrees, I would have 90 degrees. Let's add 30 more. I'm at 120 degrees. Add 30 more, we're at 150. Add 30 to 80. Add 30 to 150, we get 180. Add 30 to 180, and we get 210. Add another 30, we get 240. Add another 30, we get 300. And add another 30, we get 330. Okay, so now I'm going to do this in terms of adding 30. So 30, 60, 90, 120, 150, 210, 240. Okay, so what I've done is I've added 30 to get each of the next yellow ones. So now let's convert all of those to radians. So to go from here to here is pi, right? But how many yellow spots do we have? 1, 2, 3, 4, 5, 6. So this is really 1/6 pi over 6. This is 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6, which is 2 pi. Okay, now these two could be simplified, right? This is pi over 3, and this is 2 pi over 3. And this could be simplified. That's 4 pi over 3, and this is 5 pi over 3. Okay? So, and I could have found out any of these simply by using this conversion factor. Let's just pick a random one. Let's just pick, let's say we want to convert 150 degrees to radians. Okay, well then what I would do would be, okay, so I've got 150 degrees, and I'm going to use my conversion factor, which is pi over 180. And so the degrees here and the degrees here cancel out. And if I was had a radian converting it to degrees, I would have switched the pi and the 180. I'll show that in a second. So the 0 and the 0 cancels out. I've got 15 pi over 18. And it looks like 3 goes into both of these. So we've got 5 pi over 6. And lo and behold, that's the answer on here. So let's just say I didn't do this whole circle thing. I could simply use this conversion factor to figure out the degrees. But this unit circle is very important, as you'll see in section H8B. But let's do another example where we're going to convert something from radians to degrees. So let's convert let's convert pi over 4 to degrees. So we already know the answer is 45, right? But let's just use the formula. So we've got pi over 4, and I'm going to multiply it by our conversion factor. And like I said before, this time I'm going to use 180 over pi. And so as you see, the pi on the top and bottom cancels out. And now I've got 180 divided by 4. And 180 divided by 4 gives me 45 degrees. So there you go. You're going to be using that conversion factor to convert degrees. And you will also be using these two formulas to find length and area. Hope this helps.